and welcome to the Application 9 walkthrough for Upward Bound Integrated Math 2. Today we're going to look at some applications of solving quadratic functions by factoring. So I want to look at some of these problems and at least give you an idea of how to complete them. I don't want to do the whole thing, I don't want to do all the problems because some of that should be left for you. So let's go ahead and take a look at the first two. We're trying to solve these, and these are, again, kind of usually the first couple on the application pages are kind of warm-ups to the idea that we're trying to accomplish. So they're not necessarily application problems, but they are a little bit different than the ones that we saw in the lecture today, because both of these are actually difference of squares. That's the factoring method you're going to use. And if you don't remember difference of squares, this thing's a perfect square. We have subtraction or difference, and this number here is a perfect square also. So this is going to turn into x plus the square root of 36, which is 6, and x minus the square root of 36, which is 6. Okay? And that still equals 0. There's really two ways to do this problem. And I want to finish it this way and then talk about the other way and why it all kind of works together. So if I were to solve this now using my zero product property, I'd say x plus 6 equals 0 or x minus 6 equals 0. And when I solve those, I'm going to get x equals negative 6 from this one, or x equals positive 6 from this one. Okay? And if you don't remember, more of a conventional way to write this, and this isn't required, but you'll see it sometimes, is to say that x is equal to plus or minus 6, meaning it's either the positive version or the negative version. Well, we saw that earlier when we were solving equations with exponents, and that's what this equation is. It's just an equation with exponents, and to kind of look at a different way to work it out, which definitely works, it's not really what we're looking at here though, is I could add 36 to both sides, and I get x squared equals 36. And what we did back then was we took the square root of both sides now, and I really only made you say that the answer was 6, but I did mention that it's the plus or the minus, because if I look at what number squared gives me 36, it's either 6, because 6 times 6 is 36, or it's negative 6, because negative 6 times negative 6 is also 36. Okay? So that's a different way to do it, and if you look up maybe how do I do this problem using whatever you use to look up math problems, it might give it to you this way. I'm looking for the factoring because that's what we worked on in this set of notes. On number 2, you could use difference of squares first, saying that this is 2x times 2x. And that 144 is 12 times 12. Or there's another option. You could factor 4 out because they're both multiples of 4. And when you do that, you're going to get x squared minus 36. So you can then use our previous result to come up with your answers. Either way, if you want to do the 2x and the 12, you can do that. If you want to do the factor out a common factor of 4, and then then all this stuff would go right below here because you're doing the same steps over. Okay, let's look at the next one. And so what I want to do here is I want to do number 3 and have you do number 4, because these are definitely the harder problems. These are some real application problems when it comes to solving solving our equations by factoring. So it says here that the area is 23 inches squared, and I have measurements for the length and the width of this rectangle. The area of a rectangle is just that, the length times the width. So we could say that this, 3a plus 5 times a minus 5. We could say that that equals the area. Is a capital A for area. But we also know that the area is 23 square inches. So instead of saying that that's equal to the area, I could just say that that's equal to 23. Now, that's all well and good, and that tells me something, but the issue here is that I don't have any rule like the 0 product property that's the 23 product property. I don't have that. I don't know what two numbers would have to be in order to multiply to 23. I mean, I could probably say that they've either got to be 1 or 23, but I don't know which one has to be which, and along those lines. So what we're actually going to do here is we're going to, even though I already have this factored, I don't have 0 on the right-hand side, and that's what I need to get to first. In order to get to that, I do need to start by foiling this. So I'm going to foil, your eyebrow, nose, mouth, whatever technique you use. I'm going to multiply this out, then I'm going to move the 23 over, and then I'm going to factor again. And this problem definitely gets harder before it gets easier. So foiling this out, I'm going to get 3a squared. I know that my outsides and my insides are going to be like terms, so let's just talk it through. 3 times negative 5 is negative 15, and 5 times, well, let's write it out, I guess. 3a times 5 is negative 15a. 5 times a is plus 5a. And 5 times negative 5 is negative 25. And that equals still positive 23. Okay? And now I have to combine my like terms in the middle here, so I'm going to have 3a squared. Negative 15 plus 5 is going to be negative 10a. And minus 25 there. And that's going to equal my 23. So now, finally, I'm going to move that 23 over. I could have done it a while ago, but there was no way. I can't just subtract the 23 from this 5 and call it good. That's not going to work out. And it's not the best way to do it. It may actually, in a roundabout way, work out, but there's still a lot of work to be done that way. So let's go ahead and subtract this 23 over, and it's going to be subtracted from the negative 25. So I'm going to have 3a squared minus 10a, and if you're unsure, that's going to be a negative 48. Okay, and that's going to equal 0. So now we're to the kind of starting point of most of our problems that we covered today. So that's why this is an application problem. Okay, there's no common factors that I can factor out of the 3, 10, and 48. So I'm going to use my bottoms up method, and we're going to say that we have a squared minus 10a, and this is where this is going to get a little bit tough. If I go 48 times 3, I get 144. So it's still a negative, and it's 144. And now I have to think of two things that are going to multiply to a negative 144 and add up to a negative 10. I know 12 and 12 gives me 144, but that's not going to work out for us. So let's try some other things. Let's divide it by, well, let's just go 2. 2 and 72, if I subtract those, I get 70. If I add them, I get 74. Neither of those are 10. So let's go maybe 4. 4 and 36. If I subtract them, I get 32. If I add them, I get 30, or I get 40. So that's still not good. I need to get to 10. So let's try maybe 6. Yeah, 6 should work. 6 and 24. 6 plus 24 is 30. 6 minus 24 is 18. So that's still not there. Let's try one, well, maybe a couple more. So that was 6. Let's try 8. 8 and 18. That one looks good because 8 minus 18 is 10. Okay. Now I just have to get my signs right. I want a negative 10, so it should be a negative 18 and a positive 8. So let me write that down. Negative 18 and positive 8 are going to be my two numbers. Okay. So let's go ahead and write that. I'll have a, let's go minus 18, and a plus 8. And I have to do my bottoms up step of dividing each of these by 3 because that's what I multiplied by. That was my leading coefficient. And I know that this one reduces, this one doesn't, so I'm going to bottoms up that 3 up there, and that's going to be a 6. So we'll have a minus 6. And here we'll have a 3a plus 8. And that all equals 0. So that's well on our way. That's close to what we want to do. I do need to solve both of these. I need to set them both equal to 0. So either a minus 6 equals 0, in which case a would equal 6. Or if 3a plus 8 equals 0, I would subtract 8, then divide by 3. So we would get a negative 8 thirds. Okay? And then to kind of think about our answers, one thing that, this would definitely work for an answer. If you left it with this, that would be great. You're accomplishing the goal that I want you to accomplish. The issue is when we start dealing with things in geometry, we can't have negative side lengths. Okay, I can't have a side length on a rectangle of -5. That just wouldn't work out. So I do have to kind of test my answers. If I plug in a negative 8 thirds right here and then I subtract 5, I'm going to get a bigger negative. So that one's not going to work out. But if I use 6, for a, if I think about it being 6, 6 minus 5 is 1. So that works out. That could be a 1. And then 3 times 6 is 18 plus 5 is 23. So those two work out, and they give me the area that I wanted. 1 times 23 is 23. Okay? So I would say a better answer, as just a standalone answer, would be 6. Okay? That's kind of the advanced answer. The sort of intermediate answer is both of these, and that would be acceptable to me. But knowing that we're dealing with a geometric idea of area, I can't have negative numbers. Okay. Let's look at some hints on this last problem. So it says here to use the function f of x, or y. You can think of this as y equals. That's the same thing. X squared plus x minus 6 to answer the following. So they want us to complete the table. So you plug in numbers. Okay, that's what this means. I want you to say, what happens if I plug in a -5? So -5 squared plus -5 and minus 6. -5 squared is 25. Minus 5. Oh, come on. 5. That's an ugly 5, but we're going to live with it. And minus 6. So that's going to be 20 minus 6, which is 14. So at -5, wherever that may be right here, it's up here at positive 14. So it's actually off my graph. Okay, so I can't really can't really get an idea of where that is. We are graphing this, okay? You could use your negative b over 2a and do what we did in the graphing quadratic section, but I want you to fill out this table of values, knowing that the 5s aren't going to be on the graph. But you can continue that with the other values. I strongly suggest using a calculator, because most calculators you can go up and just edit the -5 that I plugged in, and I can edit that to be a -3 or -1, 0, 1, and so on. Okay. You are plugging in more numbers on the positive x-axis side, so you get a little better idea of what it does. And then they want you to put the function into factored form. Okay, so somehow I'm going to get some U shape that I don't want to figure out what the vertex is. Okay, this isn't exact, obviously, because it wouldn't go that way, but it's going to do something like this. Okay, it definitely doesn't have this little bow out, but that's okay. Figure out what that looks like. It's going to look something like a U shape, and that you're going to find that from plugging in these numbers and trying to make it a smooth curve like we talked about last time. And then they want us to put it into factored form. What that means is take this x squared plus x minus 6 into factored form. Well, if I think of two things that multiply to give me -6 and add up to give me +1, that's seeming like a 3 and a -2 to me, mainly because I've done this a lot. So I get x plus 3 and x minus 2. And that's what my function equals. That's my f of x. It's an equivalent statement to what they gave me. So I could use this as my function. And you can actually use this if you want to and plug in these values. I don't think it's any easier. But if I were to plug in a -5, I'd get -5 plus 3 is -2, and -5 minus 2 is -7. Yeah, -7. So -2 times -7 is 14. So it works out. Again, I'm not going to say it's much easier, but it does work out. And this is part B done. Okay, don't think that you have to do any more there. But part C says, based on the graph and what you got here, what is the connection between the x-intercepts, or where it crosses this x-axis? What is the connection between that and this form? How does this tell us anything about where our graph crosses these x-axes, or crosses this x-axis? Okay. Note that my graph is not correct. Okay, that's just a general idea of what it's going to look like, but there will be a connection between this red line, this U shape that you get, and the factored form. I want to know what that connection is. Okay, so that being said, that's some good enough hints. I do want a good answer here, and it's not a a number answer. I want you to explain the connection between these. Okay, it's a pretty big result, and it's a really big reason why we want to be able to factor, because it can help out our graph. Okay, it can give us some quick insights to our graph. So get the rest of those problems done, and keep in mind next time we meet on Wednesday, we will be wrapping up the class. I'm going to be scoring all of your workbook pages and things like that. So get all your questions answered. I may or may not throw out a final exam kind of review video. We'll see about that. But feel free to ask me questions. You can email me. You can leave them in the comments of the video. Multiple ways to ask me questions. But good luck, and we'll see you next time.